Hey, what's up everyone? This is a part 2 for a 2-cycle thing I'm doing, and this is going to be about 2-cycle fuel. Now, haven't seen the first part of it. If you don't know if you have a 2-cycle and you need to figure it out, watch that previous video. He goes over a lot of useful information, and now we're going to go over 2-cycle fuel. So if you have a 2-cycle, pay attention to this part because it will save you a whole lot of money. So we're going to go over things in a couple areas. We're going to go over what is 2-cycle fuel, how do you make or potentially even purchase if you want to, and what does 50 to 1, 40 to 1, all those 2-1 mixture numbers you see on your machines mean. And then just to kind of really hammer it home, I'm going to give you a couple of scenarios of what happens if you go lean or rich. So first things first is, what is 2-cycle fuel? Here is a mixture of oil, which is that, and gasoline. More specifically, non-ethanol gasoline. That's not required. I'd highly recommend it though, but it's not required. So gasoline by itself is a horrible lubricant. Horrible. Oil by itself is a horrible source of ignition, unless you're having, it's like a weird, I don't know, just a horrible source of ignition, especially for something like this. So that doesn't combust very well. This doesn't lubricate very well. But when you mix the two together, you can get a desired outcome of having both lubrication and a combustion. Probably should have done that the other way. So that's what 2-cycle fuel is. It is fuel that's designed or mixed to allow a 2-cycle motor, which has no oil in it. That's usually a way how you figure out if you do have one, to operate without exploding on itself. I'm not going to explain how, watch the first video, but that is what 2-cycle fuel is. Just a fuel that allows that machine to run for as long as it's physically able to, and hopefully as efficiently, which is going to come to the next part. So how do you get 2-cycle fuel or make it? Well, it's pretty easy. Like I said, I'd recommend getting non-ethanol, but if you can't, it's okay. Get your gasoline, put it into however many gallons. You probably, unless you use it consistently, 1 gallon is going to last a long time. For this demonstration, I'm just going to do 1 gallon. So in here is 1 gallon of fresh fuel. And that's a key thing, fresh. If this was filled more than a few months ago, don't even bother. Don't do that. Just go to the gas station, get a full gallon. Next, you have a few options on what you can do with, I'll just take that spacer out of here, of how you can mix it. I prefer this way. This way is significantly cheaper, but that's going to take a long time to go through. But if you use a lot, professional, that would be a good idea. You can buy single containers that basically is good to go. Just pour it in and you're fine. We're going to go over what to read on that though. And then you have the larger one, which is generally good for, it depends on how much you need, but it's good for a long time, usually about 5 gallons or so. So depending on what your usage, use it a lot, only have a small leaf blower potentially, or maybe you have a few other pieces of equipment and you'll use it regularly. That could be a good option. Basically, it just goes by cost and convenience. That costs more, it's very convenient. That costs less than that, at least, and it's a little bit less convenient, but it's still convenient. And this is the least convenient, but it costs the less to make per gallon. So it just depends on what you need. So that's basically how you end up mixing it. You take the appropriate amount, which is the next part, and you mix it in there. You pour it into the gasoline, you give it a good shaking. Here's a little side note. If it's been sitting for a while, not necessary, but it's a good idea to give it a shake. You don't want to risk having it kind of dilute out or separate. Give it a good shaking, and it should be mixed. Sometimes if it's a larger container, you might want to stir it. If you can't shake it, just whatever way you need to do it, get that thoroughly mixed together. There shouldn't be lean and there shouldn't be oily parts and more gas parts. It should be evenly mixed. So now that we know that, we have, what does that 50, 40, 32 or whatever to 1 mean? Well, basically what they are saying is, let's say 40 to 1 for instance. For every 40 parts of gas, it needs 1 part of oil. That's what it means. It kind of gets a little hard from here. That's why the most convenient way is this one. I wouldn't recommend this type, but it's not horrible, but I just don't like it. If you look right here, hopefully you can read that. That says this makes a 40 to 1 ratio for gas, or for 1 gallon of gasoline. So if you need a 41 mixture, that one container put into this 1 gallon will be the perfect amount. Now, if you don't need, or if you don't like that idea and you actually need to measure it out because you bought one of the bigger ones, what you end up having to do is a little bit of math. I know, I'm sorry. Not really a good metric person, but they really did have a good idea. If you are doing this in metric, it's a whole lot easier because like 1 liter, for instance, is 1,000 milliliters. 50 to 1, that's a whole lot easier to calculate just because everything's base 10. I personally think it should be like that here, but I wasn't taught that. I know ounces. So we have a little math to do, at least where I live, and maybe potentially you. But if you use the metric system, just know that's a whole lot easier. This whole thing will apply, but I'm going to do this one in ounces. 1 gallon is 128 ounces. 5 gallons, multiply that by 5. Next, you need to know how many ounces of oil to put in there. So let's do the same thing, 40 to 1. So we have 128 divided by, that's this symbol. Hopefully you remember math class. 40. What does that say? 3.2. So we need 3.2 ounces of oil in there. Now when you buy these, must be the other side. Oh, here we go. They usually have markings on it. They're generally rated for 50 to 1, 40 to 1, 32 to 1, and apparently, those are just the common ones. So what you end up doing is take the cap off, squeezing the bottom. That forces the oil up until it gets to that level. I do it a hair more because it's oil. You're not going to get all of it out there. It does coat the lining. And then once you have the right amount that you need, pour it in there. Same as before. Rinse and repeat, shake. Now, let's say you went to the less convenient route and you just bought the big container. They make little containers that have those markings on there everywhere. A lot of home areas actually have one designed only, garden areas only for that. I mean, pretty much any way to measure. Personally, I'm cheap. I just pour it in the top of that one and pour it. That's my measuring cup. So, yeah. So now we know what that means. This is a 50 to 1 machine. So why don't we do this together since we already have it on the other one. For 128 ounces, divide that by 50 to 1. Okay. Well, let's just say that turns into, right there, 2.6. 2.6 ounces. I mean, technically, it's 2.56, but no one's ever going to notice the difference. Anyway, so now that we have that done, what happens if you don't mix this right, if you don't put enough, if you put too much. Let's discuss this real quick. I'm going to go in order of best case scenario and worst case scenario. Best case scenario, you're going to be mixing too much. What you're going to notice is this. A perfectly running machine beforehand is going to start to have a little bit of a smoke come out of the muffler. Potentially could be a little low on power. You're going to notice that your spark plug is very carbony. That's a good indication your fuel is too rich. Now, I'm going to caution on this one. What you should do is pour the fuel out. If you can, if you just mixed it, you could potentially pour it back into the container. Redo your calculation. That's going to be a little hard. Don't just add straight fuel in there, and if you do, like you absolutely have to use this right now, try and mix it up as best as you can. Don't just pour it in there and leave. You're probably going to be fine depending on how big your tank is, but why do you want to risk it? You don't. So that's how you're going to tell. Now what does that do? It's going to plug your exhaust port eventually. It's going to plug your muffler potentially. There sometimes is a screen or mesh in there. There most definitely is a spark arrestor screen, which that can definitely get plugged up. And when that happens, you're going to have no throttle. You're going to have a whole lot of lack of power problems, and that generally isn't a good thing. But I've also seen this many of times when you think you have a blown motor, but you are for sure you put enough oil in there, and you were so sure you put enough oil in there, you doubled it or put 50% more or whatever, so you don't want that to happen. That oil can start to build up carbon deposits and actually taking those rings and not allowing them to expand out. Like they will just be compressed in there, and you're going to be losing a lot of compression. And eventually you think your motor's blown when all it is are stuck piston rings. In fact, I've worked on 2 of this type that is the exact same problem. This is a EBZ 8550 for reference. So that can happen. Something that's can occur. I don't want to say I've seen it too often, maybe 1 or 2 times, but if you have a whole lot of carbon, especially around this exhaust port, and one day it just gets brittle, that can scrape the piston or the cylinder wall, then you do have a blown motor. So you don't want to do that. Too much carbon is bad. Now let's go to the more of a worst case. Mix it too lean. Well, mixing, depending on how lean you mixed it, you could potentially blow your motor the very same day, or you can be causing it to overheat and slowly over time wear it out. If it says 50-1, put 50-1 in there. If it says 40-1, put 40-1 in there. If it says 50, if you want to do 45, go right ahead. But just know it was designed for 50. Put 50. That's it. So being lean, it's going to drastically lower your life of your machine, and potentially to the point where it could be even the same time that you just filled up with 1 tank, depending on how low you put it in there. You don't want that to happen, so that's going to be a cause of having too lean of a mixture. So hopefully this was a benefit for you on knowing what 2-cycle fuel is, how to mix it, what happens if you don't mix it right, or if you don't use the right type of fuel. So if this was a benefit to you at all, leave a comment, definitely put a thumbs up, subscribe, follow me on Small Engine 101. Any questions, I'd be happy to answer them. Leave a comment, and I'll see you in the next video. Have a good night.